Today we're diving into a paper that explores the use of multimodal pre-training for improving mathematical reasoning in large language models. The paper introduces InfiMM-Math 40B, a new dataset designed specifically for this purpose. What are the key challenges in training LLMs for mathematical reasoning?
One of the main challenges is the need for large-scale, high-quality datasets that encompass both textual and visual mathematical concepts. While there are some existing datasets, they are often limited in size or scope, hindering the development of truly robust models. Another challenge is the complexity of mathematical reasoning itself, which involves multi-step problem solving, logical deduction, and the ability to understand and interpret visual representations.
So how does InfiMM-Math 40B address these challenges?
InfiMM-Math 40B is a large-scale multimodal dataset that combines text and image data extracted from CommonCrawl, a massive repository of web data. The dataset contains 24 million web pages, 85 million associated image URLs, and 40 billion text tokens, all meticulously filtered and processed to ensure high quality and relevance to mathematical concepts.
That's a significant amount of data. Can you elaborate on the data collection and processing pipeline?
The process starts with filtering CommonCrawl data for Chinese and English web pages related to mathematics and science. They then use a combination of rule-based and model-based filtering techniques, including fast text classifiers, to identify and remove irrelevant content. This ensures that the final dataset contains high-quality mathematical content.
And how do they handle the multimodal aspect of the dataset?
They extract image URLs from the web pages and align them with the corresponding text, preserving the original sequence of content. This creates interleaved image text documents, which are crucial for training multimodal models. They also download and filter the images to ensure they are relevant and unique.
So they have this massive data set. What kind of models are they training on it?
They use a combination of visual encoders and LLMs. The visual encoder extracts features from images, and these features are then combined with text embeddings and fed into the LLM. They experiment with two different LLMs, DeepSeek Coder 1.3b and DeepSeek Coder 7b.
And how do they train these models?
They use a three-stage training approach. The first stage involves modality alignment, where they use a general-purpose image text dataset to align the visual encoder and the LLM. The second stage is continue pre-training, where they train the models on the InfiMM-Math 40B dataset to enhance their mathematical knowledge. The final stage is instruction fine-tuning, where they use a variety of instruction datasets to improve the model's ability to follow instructions and solve mathematical problems.
That's a comprehensive training process. What are the key results of their experiments?
They evaluate their models on two widely used multimodal math benchmarks, MathVerse and We-Math. Their models, which they call InfiMM-Math, achieve state-of-the-art performance on both benchmarks, outperforming other open-source models and even some proprietary models.
That's impressive. Can you elaborate on the performance gains they see?
On MathVerse, their 7B model outperforms all open-source models, including LLM-Next, which uses a 110B LLM. It also surpasses Gemini Pro and QuinnVL Max, trailing only behind GPT-4v. On We-Math, their 7B model outperforms LLM models with 72B and 110B LLMs, demonstrating the effectiveness of their dataset and training approach.
So they're seeing significant improvements in mathematical reasoning capabilities. What are the key contributions of this paper?
The paper introduces InfiMM-Math 40B, the first publicly available large-scale multimodal dataset specifically designed for mathematical pre-training. This dataset fills a critical gap in the open-source community, providing a valuable resource for researchers working on multimodal mathematical reasoning. The paper also demonstrates the effectiveness of this dataset through extensive experiments, showing that models trained on InfiMM-Math 40B achieve state-of-the-art performance on mathematical reasoning benchmarks.
That's a significant contribution to the field. What are some of the limitations of this work?
One limitation is the reliance on a pre-trained visual encoder, which restricts the model's ability to learn and adapt to new visual concepts. They also acknowledge that their model underperforms on tasks that rely heavily on visual understanding, such as the vision-only section of MathVerse. Future work could focus on developing more sophisticated vision encoders